Hello everyone, welcome to Solve First Classes. This is Tushar Shaw, and in this video we will be continuing to solve the BHU PET 2020 questions that we were solving since the last quite a lot of videos. I've forgotten the count. So basically, many videos up till question number 19 we had done in the last video, and as you can see that I have already shown you the question number 20. So we will be discussing about it in quite details, after a few minutes. So let us firstly discuss about the topic that is BHU PET 2020, what the paper is like, and what kind of exam is that. Okay, so basically BHU PET is an exam conducted by Banaras Hindu University for admissions in MSc chemistry. Okay, basically not chemistry, other subjects are as well, but we are concerned about the chemistry. But we are obviously discussing our topic chemistry. So for that purposes we have the MSc chemistry. So the BHU PET gives admission in MSc chemistry. Okay, now we are solving the paper of 2020, obviously, as I have already told you. Yeah, so and the next thing that I would like to mention that PET exam, the normal question pattern includes 120 questions of this set, for which you will be provided 2 hours to solve all of them. Okay, now this is extremely less, like according to my estimation, because in the other standard exams also, like PUMDET, TIFR, or JAM, or like all those kind of exams. So for those, like for example, let us consider JAM. JAM has 60 questions and can be solved in 3 hours, but here we have 120 questions that that we need to solve in 2 hours. Okay, so basically the double triple will be the the preparation and the practice that you need to do for solving these questions. Okay, now the question pattern also includes that 2 marks will be awarded if you have answered the option correctly, and half marks will be deducted if you have for every wrong option that you choose. Okay, so this was all about the introduction. As we are solving many two questions in this video, so let us look into the details and see whether we can whether what are the concepts. Okay, so the structure of alpha terpenol is, okay, so terpeneols are of 4 types. Okay, so let me just draw the structure for you. um, are of 4 types. So let me just draw the all the structures of terpeneols which exist normally, so it will be like easy for you to understand. uh, okay, so these are the 4 terpeneols which exist normally. This one is known as the alpha, this one is known as the beta, this one is known as gamma, and this one is known as delta. Okay, so these are 4 terpeneols, and obviously the structure requires then the question requires the structure of alpha terpeneol is. Okay, so obviously you, as I mentioned, this one is the alpha, and you can compare it in the options that option A is the option which we have drawn in the alpha case. So option A here would be the correct option. Okay, now we won't be stopping our discussion on terpenols over here. So why I have mentioned this alpha, beta, and gamma terpenols, because they have this tendency to be rearranged in some cases. So let me just draw those structure for you, and then we'll be we'll be having like for all those structures. Okay, so yeah, so we'll be interconverting between all of the structures that are there using we are not using chemical reagents in this case. We will be using certain types of bacteria and biological reagents or enzymes for conversion of alpha, beta, and gamma. Okay, so let me just show you the conversion of the terpenol, so it will be like easy for you to understand the mechanism quite correctly. Okay, so this one is basically the substituent of terpenol, which is which on providing with A. So let me just finish the structures drawing, and then I'll be mentioning what are the reagents that are taken. Okay, So we will be having the alpha terpineol over here. Um, yeah. So then if we provide A comma B, we will be getting another type of structure, um, which is basically OH, again OH, and we have OH. Okay. Then if we if we take this and provide C and D, we will be getting product like OH. And if we provide this with A, C and D, we will be getting a product like OH, OH. And if we lastly provide just A again, so we will be getting uh, here we will be having OH, and the reaction would be O. Okay, so basically these are the from the terpene, alpha terpene, we can convert it like this into the alpha terpene derivatives. And obviously from this case also you can learn about beta and gamma also. So yeah, so that was all about the the conversion. Now let me just remind you the what are alpha and beta over here, A, B and C, D. So A is P digitalitum. Okay, P digitatum. Okay. B is penicillin species. Penicillin species. C is A Niger, and D is Catharanthus roseus. Catharanthus roseus. Okay. So basically these are like four different types of bacterial species which are there, which make terpenes and its derivative undergo these kinds of reactions. Okay. So as I have told you, option A would be the correct answer. So let us move on with the next question that we have. So let me show you the next question. So piperine on hydrolysis with alkali gives. Okay. So basically, let us draw the firstly. Let us know what piperine is, and what alkali hydrolysis of piperine would be providing us. Okay. So let me just change the refill for you. So piperine has the structure. Okay, so this would be the structure of piperine, as we all know. Like it is obviously a new kind of structure. Not many students know about it, but that is okay. So we'll be putting it under hydrolysis with alkali. Okay, so alkaline hydrolysis will be taking place. So we'll be providing NaOH with H2O. Okay, so what would happen is, so let me just write down the mechanism over here. So we'll be giving OH minus into the system. Okay, so what would happen is, obviously OH minus would be attacking on this carbon, this bond will be going up. So we will be having N, we have O minus, we have OH, and the other things will be there as it is. Okay, then this bond will be falling over here and this bond will be released. Okay, so basically we will be getting um, sorry. So first of all we will be getting okay. So this compound, first of all we will be getting the name of this compound is pipperic acid. Okay, and other than that you will be getting just this part will be removed from the system. We will be getting this compound is named as piperidine. Okay, so you will be getting these two products as our main. Okay, so you can see that pipperic acid and piperidine is obviously given in option B. So option B here would be the correct option. Okay, So this was like about the main option. Now let us look at the other structures that are given. So why those structures cannot be formed. So basically piperonilic acid. Okay, so let me just draw the structure of piperonilic acid for you. uh, O O, and we have double bond O OH. Okay, so basically this is piperonilic acid. Now from here will be double bonds obviously. Okay, so from like this structure, how can we get this piperolinic acid? If the attack was from, like, if we had deleted this all this part, or if the attack was a conjugated attack, then it might have been possible. Like let us say if we attack it via let us say or any organometallic compound, basically either lignite reagent or more preferably the lithium organolithium compounds. Okay, so in that case piperolinic acid would have been formed, but not with piperidine. Okay, then this part as a whole should have been substituted, then we have been gotten a substituted piperidine product. But so obviously option A is not formed at any case. Okay, then we have option D. You can see pipperic acid and 2-methyl piperidine. So with pipperic acid, this piperidine which is getting removed, it doesn't have any substituent. It is only getting removed as a minus charge over here, which takes up the hydrogen from the water that is present in the system, giving us the normal piperidine. So therefore 2-methyl piperidine cannot be obtained. Okay, the last is protocatechuic acid. Okay, so let me just draw the structure of protocatechuic acid for you. So we have C double bond O OH, and we have here we have OH and OH. This one is known as protocate, uh, very difficult spelling it has, catechoic acid. Okay, so this one basically cannot be formed anyhow. Like it can be formed when piperolinic acid undergoes extreme hydrolysis, so that this CH2 group is removed from the system. Then we will be getting this product as the major product. But we already know that piperolinic acid is already not formed, so we can get protocatechuic acid from this purpose. Okay, so basically this was so therefore option C also cannot be formed. Okay, so let us end this video here. I hope you have learned a lot about the terpenol structure determination, the simultaneous reactions regarding that, and the hydrolysis of piperine to give out different products. Yeah, so let us end this video here. I guess you have learned like many things, so hopefully it will be like very beneficial for you in your future studies. So thank you guys for this video. I'll see you guys in the next one.